change in x. You guys see that? Yes? Kritik, are you here? Jonathan? You guys okay? So the mean value theorem only tells you is that there's one place where the tangent is going to be parallel to the secant. And this is something that you've kind of seen because remember that problem on your test on that velocity stuff? Yeah. Okay, remember the one that asked you about average speed? Right? And it was like SB one end minus the other end over B minus A. Okay, this was average speed in that question, okay? The mean value theorem is telling you that someplace on a graph like that, the average speed is going to be its instantaneous speed because S prime is instantaneous velocity. You guys remember that from the test? S prime was instantaneous velocity? Yes? So you can see the connection between this and what we did on that question in the test. Okay? So here's instantaneous. Okay? So at some point the instantaneous is equal to the average. And that's the statement that I have in words next, okay? So instantaneous change of a function is equal to the average. So whenever you think about instantaneous, you want to think about differentiation, okay? Derivative. That's what you want to think about, derivative. Get this down, Kritik. All right, let's do an example then. Oh, in words. Yeah, this is important. Okay, this is important because this is actually the mean value theorem statement. So there are really two equations that you see in here. There's this one here and this one here. And both are really the same thing stated in a different way. Okay, it's like saying 1 plus 1 equals 2 or saying 2 equals 1 plus 1. The same statement stated differently. Okay, so this is the math we'll be using to solve problems. Okay, so in A, answer the question. Is the function continuous in the domain? In A? Function continuous in the domain? Why? Nice. Is it differentiable? Yes. Same reason. Okay, so when I say just do it, I want you to find C such that f prime of C satisfies the mean value theorem. Okay? So what I need to do is I need to differentiate first. F prime of x. Someone help me with f prime of x, please. Yeah, Stephanie?
3x squared minus 2x. Minus 2.
Minus 2. So everybody there, you don't want to use the product rule here, okay? Distribute the x through first, okay? So you get x cubed minus x squared minus 2x. Someone make sure Felix doesn't fall down. Yeah, make sure you don't fall. You're fine? Okay. Everybody get f prime of x on this thing? Is everybody all right? Then I want you to find the slope of the secant line. Remember, the slope of the secant line in this context is going to be f. What is a equal to in this one? And b, 1. So you're going to go fb, so that's f1 minus f of minus 1 over 1 minus minus 1. So someone help me, what's f of 1? What the F?
-2.
What the? Oh, you're right. -2.
Yeah.
What's F of -1? Okay, is everybody there?
It's between F and
Yes, you can see it there because there's no prime on the F's there. So F of -1, 0 over 2, which is equal to -1. Then you're going to set this equal to F prime, which is this. So set it equal to 3x squared minus 2x minus 2. So you get an equation now, right? How do you want to solve that? What do you want to do? Sorry? How are you going to factor it the way it is? Thank you. Okay, so then this becomes 3x squared minus 2x minus 1 equals 0. In other words, make it look like a quadratic equation, which we know how to solve. Okay, and now, Sajal, you can do what you are suggesting. Do it. Now I'm waiting for your answer here. 3x plus 1 or minus 1? Plus 1, and on the other side? So x equals -1 over 3, or x equals... X cannot be equal to 1 because that's at the end point. It cannot be at the end point. So we know that we're not going to look at that. Okay? So can you guys get a graphing calculator out and graph that and show that it looks like the tangent line is parallel to the secant line? So remember, you're graphing F, okay? And you, for your window, you're going to use -1 to +1. And you probably looks like you want to change the y value. So make your y go from -1 to +1. So in here, your secant line is this line here. Okay? And what was your C equal to? -1/3? Yeah? So then if you look at it, say -1/3 is, I don't know, somewhere out here, then it's saying that there's a place where the tangent line is parallel to the secant line. Not drawn precisely, but you get the idea as to what's going on. You guys okay on this? Okay, you do, since I did.
What was the joint effort?
How joint was it? Like 2080, 1090, 95.5?
64.
Okay, well then how about you try this, and if you need help, I'll help you, okay? Number 39, page 177.